Hi students, in this video we're going to look at the graphs of circles. So the learning goals for this video, after watching this video you should be able to recall the equation of a circle. That'll be one of the first things we do. Determine the center and radius of a circle from an equation. Determine the points on a circle if you know the x or y coordinate, and then calculate points of intersection between lines and circles. Alright, so some things to recall. So the definition of a circle is a good first one. So a circle is shaped like this one, all round, where every point is the same distance from the center. Right, so each of those distances, that distance from the center to the edge of the circle, they should all be the same, right? We know those as radii, but for our circle, those distances are all the same. And that idea will be helpful to understand when we start talking about where this formula comes from. Remembering Pythagoras' theorem will be very helpful, and then solving simultaneous equations using substitution. That will be used when we start finding the intersection points between lines and circles. Alright, so looking at our equations here. Okay, the equation of a circle with the center at 0, 0 is x squared plus y squared equals r squared. It should look a bit familiar, especially since we saw it on the last slide. That's just Pythagoras' theorem. So where does that formula come from? Let's say we've got this point here. Okay, there's our length. Let's say this distance here is our x value. This distance here is our y value. This distance here we know is our radius, right? That's just our definition of a circle, from the center of 0, 0 to our edge. That distance is our radius. Now, if we were going to write an equation with these, we can see that we've got a right angle triangle. R is the hypotenuse, x and y are the other sides, and we've got a right angle here where where this height here meets with our horizontal x-axis. So using that, we can write it using Pythagoras, which is where we get our equation. For Pythagoras, it's a squared plus b squared equals c squared. Here, a and b are x and y, so x squared plus y squared. And then that equals our hypotenuse squared, which here is r squared. And that value, that formula, must be the same the whole way around because r, our radius, doesn't change. The key thing to notice here, students, is that the radius is squared. So looking at this circle here, we can see it's got a radius of 5. Right? From the center up to the top here is 5. From the center to the right is 5. In all directions, our radius is 5. So if we want to know the formula of this equation, the center's at 0, 0. So it's x squared plus y squared. And our radius is 25 because that's the value of 5 squared. So most often, students, the error will be students don't square the radius, right? They might say x squared plus y squared equals 5. That is incorrect because just like Pythagoras, everything has to be squared. So our radius here, which is 5, has to be squared to give us 25. All right, let's use that in solving some problems. So for the circle x squared plus y squared equals 25, determine the values when x equals 2. All right, so all we're going to do then to find out those y values is substitute in x equals 2 into our equation. So we'll have 2 squared plus y squared equals 25. 2 squared is 4. So if we subtract 4 from both sides, y squared equals 21. Now to find out our y value, it's going to be the square root of 21. But remember, students, when we take a square root, our answer could be positive or negative value of that square root sign. So the square root of 21 is not square root anymore, it's 4.58, and that answer could be positive or negative. Now, how we make sense of that with our diagram is we've got our value here of x equals 2. Up here is our value of positive 4.58, and then the negative value that we get here is down at the bottom part of our circle here. and that's negative 4.58. That's why we've got these two values. We've got the y value above 2 and the y value below 2, the positive value and the negative value. So that's why we need the plus or minus out the front, and that's how we make sense of it. Right, our last problem, determine the points of intersection of the circle x squared plus y squared is 25. So again with our same circle, and y equals 3x. So y equals 3x, it's got a y-intercept of 0, gradient of 3, so 1 across, 3 up. So our graph should look something like that, and something like that. So we'll have one intersection up here, and one intersection down here. Now all we're going to do here, students, is do some substitution. So we'll call that first equation, equation 1, second equation, equation 2, and we'll say sub in 2 into 1. So subbing in, we've got x squared plus, now y is 3x squared. Do put it in brackets, students. That's we'll show you why in a moment, but make sure it's in brackets when you square it, and that should be 25. Now x squared will stay the same. Expanding this power, we have to do 3 squared, which is 9, and x squared left over. So the most common mistake you'll see students make is we'll say, all right, it's x squared plus 3x squared equals 25. That's not correct, right? When we substitute in 3x, we need that brackets because that whole term, 3x, needs to be squared. So that 3 squared becomes 9, and the x squared becomes x squared. So simplifying that, x squared plus 9x squared is 10x squared equals 25. X squared equals 25 on 10, or 5 on 2. So x, let's go top here, x equals the positive or negative square root of 5 on 2. And that's those are our x values. So there's our positive value, square root 5 on 2, and there's our negative value, square root 5 on 2. Now subbing those values in, let's just do the positive one. Sub in positive 5 square root 2. So 5 square root 2 squared plus y squared equals 25. All right, so square root and squared cancel each other out. So we'll just have 5 on 2 plus y squared equals 25. Rearranging that. 25 is the same as 50 on 2, so subtracting that from both sides, y squared equals 45 on 2, so y equals plus or minus square root 45 on 2. Now looking at our values here, this value up here looks like it could be positive square root 45 on 2. This value down here looks like it could be negative square root 45 on 2. So therefore, our 2 points are square root 5 on 2, then square root 45 on 2, and negative square root 5 on 2, and negative square root 45 on 2. Excuse the scribbled writing there. Alright, so students, after watching this video, you should be able to recall the equation of a circle. That was from our first slide, to determine the center and radius of a circle from an equation. So if you've been given the equation, the radius will just be the square root of the constant, and then determine the points of a circle. We've done that, and calculate the points of intersection between lines and circles.